Hi everyone, welcome to the SimpliCode YouTube channel. In this tutorial, we will learn about data visualization. Data visualization is a field which deals with visual representation of data. It plots data in a graphical way and is an effective way to communicate inferences from data. Matplotlib, Bokeh, and Seaborn are Python libraries which are used for data visualization. They have inbuilt modules for plotting different graphs. So, let's hand over the session to our instructor who will guide you through the Python data visualization tutorial. But before we begin, if you love watching tech videos, subscribe to our channel, like the tutorial, and hit the bell icon to never miss an update.
So what's in it for you? What is Matplotlib? Types of plots, plotting graphs and subgraphs, adding a graph inside a graph, graph parameters, title, label, legend, line graphs, line types, color and transparency, canvas, grid and axis range, 2D plots, scatter, step, bar, fill between, radar chart, histogram, contour image, 3D surface image, and then we'll hit a practice example pie chart. So let's start with what is Matplotlib. Matplotlib is an open source drawing library which supports rich drawing types. It is used to draw 2D and 3D graphics. And there are so many packages in the Matplotlib, we're going to cover the basics. And there are so many packages that sit on top of the Matplotlib that we can't even cover them all today. But we'll hit the main ones so that you have a good understanding of what the Matplotlib is and what the basics can do. You can understand your data easily by visualizing it with the help of Matplotlib. You can generate plots, histograms, bar charts, and many other charts with just a few lines of code. And here we have some basic types of plots that you can see here that we'll go into. We have the bar chart, the histogram. Boy, I use a lot of histograms in my stuff. A scatter plot, line chart, pie chart, and area graph. Let's start plotting them. And to do this, I'm going to be using Jupyter Notebook. You can use any of your Python interfaces for programming or scripting and running it. Of course, we here really like the Jupyter Notebook for doing a lot of basic stuff because it's so visual. And in our Jupyter Notebook, which opens up in this case, I'm using Google Chrome, you can go up here to New, and we'll create a new Python 3 and set that up. If you're not familiar with Jupyter Notebook, we do have a tutorial that covers some of the basics of that. And you'll look at any of our tutorials. I usually cover a number of them showing how to set up Jupyter and Anaconda. I myself use Jupyter through Anaconda. In fact, let's go ahead and open that up and just take a look at that, see what that looks like. You can see your Anaconda navigator. If you install it, it will automatically install the Jupyter Notebook. And that also installs a lot of other things. I know some people like the Qt console for doing Python or Spider. I've never used them. I actually use Notepad++ as one of my editors. And then I use the Jupyter Notebook a lot because it's so easy to have a visual while I'm programming. And even simple script in Python, I'll take it from the Jupyter Notebook and then do a save as. You can always go under File and you can download as a Python program. So that will download it as an actual Python versus the IPython that this saves it as. So let's go ahead and dive in and see what we got going here. And let's go ahead and put Matplotlib tutorial. And I'm going to turn this cell into a markdown so it doesn't actually run it. You can see it has a nice little title there. That's all Jupyter Notebook. And then from Matplotlib, let's import PyLab. Get that back one. And then let's go ahead and just print. We'll go PyLab and the version. Let's go ahead and run this. So we're going to import our PyLab module from the Matplotlib. And we find out that we're in version 1.15.1. Always important to note the version you're in. Probably I was reading an article that said the number one thing that Python programmers struggle with is remembering what version they're working in and making sure that they're going from one platform to the other with the same version. And if we're going to graph things, I think we need some data to graph. So we're going to import NumPy as NP. Now, if you're not familiar with NumPy, definitely go back and check out our NumPy tutorial. There's so many different things you can do with it, dealing with reshaping the data and creating the data. We're just going to use it to create some data for us. And there is a lot of ways to create data, but we're going to use the np.linespace. So we're going to create a NumPy array. And the way you read this is we're going to create numbers between 0 and 10. And we're going to create 25 of these numbers. So we're just going to divide that equally up between 0 and 10. And if we have x coordinates, we should probably have some y coordinates. And we'll do something simple like x times x plus 2. And let's just take a look. We're going to print x and print y. Let me go ahead and run this. And let's see what we got going on here. So we have our x coordinates, which is 0, 0.4, 0.83, etc. And you can look at this as an xy plot. So where we have 0, we have 2. Where we have 0.416, we have 2.17. And just as a quick reminder, we're going to do print np array x comma y dot reshape 25 comma 2. And the reason I want to do this is I want to show you something here. A lot of times a program returns x comma y, and it's an array of x comma y, x comma y, x comma y. And so when you're working with the pie plot, you have to separate it out and reshape it. So if I start off with pairs like this, I can reshape them. If I know there's 25 pairs in there, I can switch the 2 and the 25. And this is kind of goofy, but we'll do it anyways. Reshape. So I'm going to reshape my 25 by 2 back to 2 by 25. And if I run that, you'll see I end up with the same output as the XY, the two different arrays in here. And this is important that we want X and Y separate. Again, that's all NumPy stuff, but it's important to understand that this is a format that Matplotlib works with. It works with an array of X's, and they should match your array of Y's. So each one has 25 different entities in it. And then for our basic plotting of this data, it only takes one command to draw a graph of this data. And so we use our, from up here where we imported PyLab, we take our PyLab, and the key under there is plot for plotting a line. And then we want our x coordinates and our y coordinates, and we'll throw in r. And the r simply means red, so we're going to draw the line in red. Let me go ahead and run that. You can actually switch this around if you wanted to do different. There's B for blue. We have a lot of fun. Yellow, hard to see yellow. There we go. But we'll go ahead and stick with red. Run. And when you're doing presentations with these, try to be consistent. You know, if the business and the shareholders send you a spreadsheet and they have losses in red, use red for losses in your graph. Try to be consistent. Use green for profit, for money. You don't have to necessarily use green, but it's whatever they're using, whatever the company's using. Try to mirror that. That way, people aren't going to be confused if you switch your data around and every time one graph has red for loss and one graph has blue for loss. It gets really confusing, so make sure you're consistent in your graphs and your coloring. And something to know, because we're going to cover this in a minute, this is your canvas size. So we have a canvas here, and what we're going to do next is we're going to look at subgraphs. Okay? So let's take our PyLab and create a subplot. And one of the things also to know when we're working with the Matplotlib, I'm not setting, when I do this, this is my drawing canvas, the PyLab. So once I've imported the PyLab, I'm drawing my images on there. Very important to know. And with the subplot, we're going to give it some different values. And we're going to represent by rows, columns, and indexes. And let's do 1, 2, 1. So it's going to be the first row, second column, and the index is like you can stack your graphs and things like that. We don't worry too much about indexes, but rows and columns. We want to go ahead and use row 1 and column 2. And if we're going to have one object, we should probably have two, but before we do that, we have to plot data onto the subplot. So the order is very important, and we'll go ahead and stick with our x comma y, and let's do this. We're going to add in a third parameter here. Remember we did red? We're going to add shorthand dash dash for dashed lines. So this plots the data into row 1, column 2. And if we're going to do that, let's do another one, pylab.subplot. And if we're going to do row 1, let's do column 2 and index 2. And this time we're going to add G for green, and this denotes a style. And if we're going to set up our PyLab subplot, here we go, PyLab, we got to go ahead and plot that. PyLab plot. And instead of XY, we want Y comma X. Whoops, I messed up. This is in the wrong spot. There we go. We'll move that down here real quick because that goes in the plot part. So the subplot tells it the row, column, and index, and the pyplot tells it what data. In this case, we switch them, and the color, and then the style shorthand. Now let's go ahead and run that. And you'll see it takes this canvas, splits it in two, and now we have two different graphs. And we have the red one with dashed lines, and we have the green one, which has the little stars going up. And if we take this, and let's just for fun, let's change this and run that with an index of 1. It puts them both on the same index. It also gives me a warning because it's a strange way of doing two subplots. It's depreciated, there's another way to do it. But most people just ignore that warning because it's not going to go away anytime soon. Now that's using the same setup. What happens if we do, instead of this, let's change the column on here and find out what happens. And if we do the column, it didn't really like that on the setup, it just disappears. So let's keep our column as 2, and let's change the row on the second one to 2 and run that. And you'll see again it kind of squishes everything together and causes some issues. So let's take the index. So they each need a unique index. And you can see here where I made some changes. I said row 2, and look what happens when I change to column 2. So I now have row 2, column 2, index 2. It squished it up here, so you could put another graph underneath is what that does. And there's all kinds of different things. You really have to just play with these numbers till you get a handle on them, because you have to repeat it 164 times according to Cambridge University if it's completely new to you. And you can see right here where, there we go, 3, run. There we go. But you can see it takes a little bit sometimes to play with these and get the numbers right. Oops, I hit the wrong one, that's why. Let's go 3 there, run. There we go. Now it's overlapping, so I have this doubled over here on the right. For now, we'll just go ahead and leave this with the where we have column and row 2 and the 2 different indexes so they appear nice and neatly side by side. And then, as we just saw, as we were flashing through them, we can put them on top of each other. And let me just highlight that and copy it down here. Paste it down there. And here we have 1, 2, 1. And then we'll do 1, 2, 1 also for this one. And that puts the 2 subplots directly on top of each other. It gives us that warning. And you can see we now have 2 different sets of data graphed on top of each other. And you can also see how it did the indexes. Since one of them is from 0 to 10, that's the green one on the x-axis, and the other one is from 0 to 10 on the y-axis. So it took the greatest value of either one and then used those as a shared value. So let's next look at operator description. And we'll go ahead and turn this cell into a markdown and run that so it looks nice. So Fig, and you remember I talked about the canvas earlier. I briefly mentioned it. We're going to look a little bit more at the canvas later on. But that's what the figure is. Fig, we're going to add axes. So we're going to initialize a subplot, add the subplot, in rows, in columns, and all kinds of different things with this that you can do. Let's look at that code and see exactly what's going on. And I want you to notice that there's Fig, which is the actual canvas in the Matplotlib library. And AX is commonly used to refer to the subplots. So when we're creating subplots, you'll see AX equals PLT subplot. Earlier, we did the PyLab. So let's go ahead and import PyPlot from Matplotlib library. And we're going to do it as PLT. You'll see that a lot. That's really the standard in the industry, is to call it PLT, just like Pandas is PD and NumPyArray is NP. Certainly you could import it as whatever you want, but I would stick to the standards. And we're going to do the same graph as we did above with the PyLab, but with the PLT. So if it looks familiar, there's a reason we're doing this, because we want to show you how the figure part works and working with the canvas goes. But we're going to do the same plot as we did before. And we'll call it Fig, and we're going to set that equal to plot figure. So there's our figure or our canvas on there. And let's create a variable called axes, and we're going to set that equal to fig.addAxes. And in this, we're going to control the left, right, the width, the height of the canvas from 0 to 1. And so we can go ahead and I'm just going to put some stuff in there. I got 0.5, 0.1, 0.8, 0.8. So when you're looking at this, this is a 0 to 1, or you could say 50%, 10%, 80, 80%. But it's a control. It's going to control your left and your right, along with the width and the height. So the width and the height, we're going to use 80%, and we're going to have like a little indent on the left and the right. And this should look familiar from above, axes.plot, x comma y, and then let's give it a color. How about red? Since we're recreating the same graph, let's keep it uniform. Oops, and it helps if I use AXIS instead of AXES. I don't know where that came from. But this looks identical to the one we had up above. So here's our axes plot, x comma y of red. Same graph, same setup, but this time we've added a variable equal to the figure.addAxes. So our plot figure is our canvas, our axes is what we're working in, and then our axes.plot x comma y. And again, we can draw subgraphs. Let me put that down here. just like we did before. And a little different notation here. We're going to have fig, comma, axes equal plt.subplots. And in here it's going to be the number of rows. We're going to do one row, and columns equals 2. So if you remember before, that's what we did. We had one row with 2 different graphs on it. We're going to do the same thing, but note how we did this. Here's our figure, or our canvas, and our axes. We're going to create actually 2 different axes. We're going to create row 1, column 2. And so axes is an array of information. So we can simply do let's do ax in axes. And this will now look familiar, x.plot. We're going to do x comma y. We'll go ahead and make it red. Keep everything looking the same. Remember, a nice uniform graph, so everything looks the same. And if we go ahead and run this, you'll see we get 2 nice side-by-side graphs. So just as we had before, the same look, the same setup. And just for fun, let's change in columns to 3. We'll run that. And now you'll see we'll have 3 on there. And let's see if we make it a little bit more interesting. We'll do in rows equals to 2. And you can see down here we're going to get an attribute error because it's trying to scrunch everything together. So it does have a limit how much stuff you can put in one small space. That's important to know. You can fix that by changing the canvas size, which we'll look at in just a minute. And there's other ways to change it on here. But here we go. We can do in rows 2 and columns equals 1. You can see 2 nice images right above each other. We'll go back to the original. 1 row, 2 columns, side by side, left to right. And we can also draw a picture or graph inside another graph. And that's kind of a fun thing to do. It's important to note that we can layer our stuff on top of each other, which makes for a really nice presentation. So let's start by fig. We'll create another figure. So we're going to start over again with our canvas. We set that equal to plt.figure. So there's our new canvas. And let's do axes. We'll call it axes 1 and 2. Axes 1 equals fig.add axes. Remember this from earlier? And this here, similar numbers we used before, saying how big this axis is, this figure in the axes is. So this is going to be the big axes. And let's do axes 2 equals another figure add axes, and then 0.2, 0.5, 0.4, 0.3. And if we're going to do this, they need data on them. So let's go ahead and plot some data on our axes. So axes1.plot. And we'll make this simply x comma y comma, make it red. And then let's go axes2.plot. And let's reverse them. Y comma x comma green. There we go. Doing what I told you not to do. You shouldn't be swapping axes around and plotting your data in 5 different directions because it's confusing. But let's go ahead and run this and see what this looks like. And then let's talk a little bit about this. We talked about the 0.2, 0.5, 0.4, 0.3. And let me just grab the annotation for that. That's left, right, width, and height. So we have in here that this is going to be left, right. So here's our left is 0.1 in. 0.5, and you know what, let's just play with this a little bit. What happens when I change this to 0.1? Moves it way over to the left. So there's our 0.1. So we can make this 0.4. Run that. There we go. So you can see how you can move it around the branches on here. 0.2. 0.5 is the left, so that's our right. So let's see what happens when we do let's make this 0.1. And that actually is, they had it down as left, right. I thought this was wrong. It's actually how far from the bottom. Let me switch that on here. Bottom. There we go. So we had here on this. We can go ahead and put that back to 0.5 and run that. And this is 0.3. Let's make this 0.3 also. And that is the width. And then, of course, there's the height. We can make that really tiny. Actually, let's do 0.2. And let's run that. And you can see it changes the height on there. We can make it even smaller, 0.2 by 0.2, and as you can see, you can get stuck playing with this to make it look just right. It can sometimes take a little bit. Certainly, once you have the settings, if you're doing a presentation, you try to keep it uniform, unless it doesn't make sense for the graph you're working on. Try to keep the same colors, the same position, and the same look and feel. And I mentioned earlier we can adjust the canvas size. So this is from earlier, I just copied it down below. We're going to replot the same data we've been looking at. And what we can do is we can change the figure size to 16 by 9. And let me run that and show you what that looks like. So it fills the whole screen. And then if you are, normally when you're working on the screen, you don't worry too much about this. But we can set the DPI to 300. Run that. There it goes. This is your dots per inch. And if you are doing an output of this and you're printing a hard copy, you want the higher quality. I would suggest nothing under 300 if it's a professional print. You might get a little less than that, but whenever I'm doing professional graphics and printing them out on something, 300 dots per inch is kind of the minimal on there. You can go a lot higher too, but keep in mind the higher you get, the more memory it takes and the more lag time and the more resources you use. So usually 300 is a good solid number to use in your dots per inch. And you can see it draws a nice large canvas here, which is 16 by 9, and then the DPI is 300 on here, so it's a little higher quality. And just out of curiosity, I wonder how long it takes to draw something double that size, 600. And you can see here where at 600 DPI it's going to take a while. There it goes, just because it's utilizing a lot more graphics on there. And let me just go back to the 300. Now let's do a 100. You're not going to see a difference on this because it is web-based graphics are pretty low. And up here you saw I did this with the plot figure. This works the same if I do figure axes subplot, figure size, and then we'll go ahead and do axes plot x comma y comma, we'll stick to red. Let's go ahead and run this. And you should get almost the same thing here. Here's our axes on the subplot on here with the fixed size and the DPI. Let me take this all out. Let me just remove all that real quick. Run it again. There we go. Now we're back to our original figure. And let's look at some of the other things you can do with this. One of the things we can do is we can set a title for the axes. So axes set title. You'll see right here, since I put this on the axes, it's the main title for the whole graph. And if you're going to have a title, you should also label. So we can label our X label, and we can set our Y label. In this case, we're just going to call it X and Y. Keep it nice and uniform, and if we run this, you'll see that we've added a nice X label and Y label. Whoops, where'd they go? And it turns out in this environment that you have to put it before the title. So let me go ahead and put it before the title. And there's our X, Y, and let me run that. And of course, we can also do up our size a little bit so you can see what's going on a little better. So here we have X label X. If you come down here, you'll see our X label and our Y label. We can, of course, change this to X label. You can change this to Y. It can be whatever you want on here, of course. And our title graph. There we go. Run. So here we have our title graph, our Y label, and our X label all set up on our nice little plot. And then before we move on to the next section, let's do one more thing on here. We have a thing called the legend. And we're going to set our AX legend, label 1, label 2 up here. That's the format for it, but let's go down here and actually use it. I'm going to do two different plots. We're going to have axes plot x by x times x squared and x cubed. And if I run this, you'll see it puts two nice graphs on the setup on there. But it's nice to have a legend telling you what's going on. So for the legend, we can actually do axes, since we have the two plots, legend. And on here, we've created an array, and we have y equals x squared, y equals x cubed. You can actually put this as whatever you want. Those are just strings. And then location 2. And let's go ahead and run this and see what that looks like. And you can see it puts a nice legend on the upper left-hand corner. Location 2. We can do location 3. And run it, and it drops it down to the bottom. Location 1, I can't remember where that's at. There we go, upper right. So each one of these is a number that refers to the different locations on the screen. 0, kind of have to play with them or look them up to remember where they're at, but they do work. It just kind of moves around depending on where you want your legend at on there. So on this section we cover the title of the graph, the Y labels, and legends. We're getting into starting to look really fancy here. So we now have something we can actually put out. You'll see the title of the graph looks a little fuzzy. So I might, in a web setup, put the DPI up a couple notches. Maybe put it at 200. 100 might work fine. Just so you know, that's something to notice on here when you're playing with these different things. We had our subplots DPI equals, let's do 200 to see what that looks like. So you can see it now is a lot clearer. It's also larger. So it's a nice little feature you can throw in there with your DPI dots per inch. So the next section is let's look at some graph features. We're going to look at line color, transparency, size, and a few more things on here. And, oops, I forgot the main title. So we have our figure and our axes equals our plot and subplots. And I'm going to go ahead and do a DPI equals 150 so the graph comes out nice and large and easy for you to see. And let's go ahead and do 3 plots on here. We'll do x by x plus 1, so it's just going to be a straight line. Plot x plus 2, and axes dot plot x plus 3. This looks like we're doing nearest neighbor setup or showing how it located data and putting your lines on there between the nearest neighbors. There we go. So it draws a nice little graph with 3 lines on it. One of the things we can do is we can control the alpha on this. Oops, and you can actually see the when they did these lines, it automatically pulls in different colors for your setup. So there's some automatic things going on in there. And a lot of times we do that comma R, where we're going to do color equals red, another notation on here. Let's go ahead and run this. Now we have a bright red line down there. And with the Matplotlib, you're not limited to red. You can also use one of many different color references, as you see here, with the pound sign 1155DD, which is just blue. And we can do the same thing with another color on here, which turns out to be green. And I can just as easily do this. Green, blue, oops, there we go, blue, and run that. And you'll see here we have red, blue, and green. And what I want to do is I want to make this, we're going to set what's called the alpha on this. And we're going to set this equal to 0.5. So this is halfway see-through when I run this. And it's almost going to look pink because you can see through it. And let's change this just a little bit, just to make this kind of fun. Let's square it. There we go, run it. So now we have this nice square that comes up. And you can see when it crosses it, because I plotted these 2 lines after it and they have no alpha, the red is behind those lines, or in this case pink, because we did the alpha halfway through. So let's go ahead and do this. Alpha equals 0.5. And, oh, you know what? Instead of squaring it, let's take it to the 0.5 power. That'll be kind of interesting to see what that does. We'll just go to keep it squared. There we go. And run that. And let's go back and look at this where it crosses over. And the first thing you'll see right here is on the blue, it's kind of light blue now. You can see how the 2 colors add together. You get almost a purple on there. So I can clearly see where the red crosses the blue line. And then the green just blanks it over because I didn't do any opaqueness, no alpha on there. So this is great if you have lots of data that crosses over and you need to be able to track those lines better. And we'll go ahead and do this 0.5 and we'll run that. Oops, I did equals 0.5. Let me go ahead and run that. And so you can see right here now you can easily see the red line, how it crosses the green and the blue down here. And if we want to, we can do this as the default is 1, is solid. So we can change this all to 0.8. Let me just do that. Oops, 58, 8. There we go. Run. Oops, I must have hit a wrong button there. Let me try that again. I accidentally got rid of a bracket. And let's go ahead and run that. And we come down here and look at this. You can still see where it passes behind them, but the green dominates and the blue dominates because we're now at 80% instead of 50%. And you can do less. That's kind of fun, although at some point the lanes kind of fade. So 0.5 is usually the best setting on there. We have a nice pastel here at 0.3, and you can easily see where they cross over. And just like you can play with the colors, we can play with line width. And let's try DPI 100 and see what that looks like on my screen. Equals 100. And we'll go ahead and just take our AX plot. Let's do 4 of these lines just so you can see how they look next to each other. Real quick here. There we go. And if I run this, they should all appear the same. It automatically does different colors on there. So let's do color equals blue. Forgot my quotation marks. There we go. And we'll go ahead and just make these all blue, just for purposes of being nice and uniform. And then what I want to do is I want to do the line width. Line width equals 0.25. And let's just copy and paste that down here. Let's do equals 1. About 1.5. And let's do just make this equal to 2. Let's see what that looks like. And when we do that, you can see it goes from a very thin line, a 0.5, a 1, our 1.5, and 2, which is twice the width of the 1. And if we're going to do different sizes, we had different colors, we had our alpha scheme. Let's take this whole thing here. Let's paste it down here and do another one. But instead of line width, let's look at styles. And something to note here, you can actually abbreviate this with LW. So line width can also be let's just do everything 0.2. And let's set up a line style. We'll do the first one dashes. And let me just paste that down here, so I'm not doing a lot of extra typing. There we go. Take this out. So we have our dashed. We can do a dash dot. Oops, let's do the dash dot here. And a colon here. There we go. And there's a lot of different options. We'll look at a few more as we go down. for different ways of highlighting data. But when you look at this, we have everything as a line width of 2, and now we have a straight line, we have a dash line, or a dot dash, and a dot 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 line. And then another thing we can add on here is we're going to do, here's our ax plot, and we did x, let's do x plus 4, so it goes right on the top. I'm going to do color black, line width 1.5, so it's a smaller line. And we're going to take the line and we're going to set dashes. So look how I've changed some of the notation here for my line and my ax plot. So I can set my line comma equal to ax plot, and then I can change the line settings this way. And when I run this, run that on here, you'll see the 5, 10, 15, 10 creates a series of dashes that are varied in length. In this case, they alternate between a short dash and a long dash. And we can play with these numbers. Curiosity always has me what happens when you play with the numbers. Just to see what they look like, let's do this. Let's paste this down here. I'll do 2 of these just because they're kind of fun to play with. And let's change this from 10 to 3. And we're going to change this one from 15 to 4. And let's run that. And you can see the differences in the lines. Oops, a little bit confusing on there, because I forgot to change the lines are all on top of each other. So let me change that really quick here. And let's run that. And now you can see here's our original dash line alternating. When I change these numbers on the second one, the very end value to 3, you can see now we have dashes of 5. Let's see, I'm going to guess this is a dashes of 5, skip 10, dashes of 15, skip 3, and then it goes back to the beginning. Dashes, 5 dashes, skip 10, 15 dashes, skip 3. And of course the last one we just switched up a little bit. It looks a lot more uniform because I'm using 2 sets of 10. Or if I did something like this and changed it to 30, it really becomes pronounced as far as the distances between them. And instead of 4, let's go, let's put 30 here also. 30 by 30, there we go. Really pronounced on that one. And let's look at one more important group for plotting our data. And in this, here's our plot we started with the x plus 1, x plus 2, x plus 3, and did it in blue on this one, 3 or 4 different blue lines. And this property, we want to add the actual plots, so you can see where the plots are on the graph. And for that, we might have marker equals O. And if we run this, you'll see it puts a dot for each of these, and there's 25 dots because we have 25 x values. So we actually have 0, and each of the different values of x, y are then plotted here with the dots. And we don't want to just limit ourselves to dots. We can also do plus sign, that's another option. Dots is most common. I actually like the dots the best. If we do the plus sign, you can see it puts a nice crosshairs or plus sign on there. And we can do a marker. There's a number of different markers you can use. And I think this one was it. S is another one, which is a nice square. And that's actually a good one, S for square. O for period. Okay, that's just kind of weird. So you can see that probably on these markers, another one is number 1. So if we run that, you'll see we now have these little hatch marks. And let's just go with the O on this one. By the way, this works with square really nicely. Some of the stuff we're going to do here on just a second. Let's do marker size equals 2. And change that to 5 and run that. And you can see here it puts a nice little tiny dot versus this size dot here. And this is interesting because it said 2. I thought it would be bigger. But if you do 0.5, it gets even smaller. And let's just do 10 to see what that looks like. Run. That looks huge. So marker size, a lot of these are dependent on the DPI and the setups. There's things that switch around as far as the way the size shows up. You got to be a little careful when you change one setting, it can change all the other markers. And then let's take our square on here, and we had marker size, we also have marker face. We'll set that equal to red. Of course, I may change so it's up 1 notch. We'll run that. Whoops, must have mistyped something on here. And I did, it's marker face color equals red. And so when I run that, you can now see I have the squares on there with the marker face color. Of course, we can mix and match these. Come down here and we'll make this, let's make this plus 7. And we'll make this size 15. Marker face color equals, and we'll do green, just because. There we go, run. Very hard to actually see what's going on there. Still 25 dots, they kind of overlap. As you can see, they print them over each other. And of course, if we really wanted to make it look horrible, we could just make that really huge. Generally though, you want something a little bit smaller and cuter. We'll just try doing it this way. There we go. That's too small to even see the face. So 4. You can start to see the face on there around 4. And maybe on 8. 8 might be a good number for this. There we go, 8. Again, that all just depends on what you're trying to show and display. So we've covered a lot of stuff here as far as our lines. We've covered opaque with our alpha setting on there. Give us some nice pastels. You can see how they overlap and how they cross over. We covered the line width, different size on there, different formats for the line itself, and these are all, you can combine all these. So you can have our line width equals 2, line style equals dash. You can bring this down here also to the markers. And then we added markers in, just standard circle, a plus sign, the square, a little tick which uses a 1. Then we add a marker size and a marker color face, and we combine those. You see we get a nice different series of representations. We also briefly mentioned color, where you didn't have to use, like in here we used color black. Someplace up here, I'd have to find it, we use the actual number for the color, as opposed to, I changed them to red and blue. So you can get very precise on the color if you have a very specific color set that you need to match your website or whatever you're working on. All of those are tools in the Matplotlib library. So we have one more piece to formatting the graph, so we want to show you, and then we have 2 big sections. We're going to go over the different graphs that they have along with a challenge problem. So let's go in the last section we're going to look at is limits. We're going to limit our data. So this first part I'm just going to paste in there. We're going to create our subplots 1, 2. So 1 row, 2 columns. We're going to do a figure size of 10, 5. This should all look familiar now since we've done a number of them. And we're going to go ahead and plot, and this is an interesting notation you should notice here. Our axes 0, so 1 we've used, instead of, you can just iterate through them, but they're just an array, so it's an array of 0 is still the axes of the first axes out of 2. And we're going to plot x squared, x cubed, line width 2. So we're going to go ahead and just plot 2 graphs right on top of each other without doing multiple plots on here. And we'll set the grid equal to true on here. Let's go ahead and run that. And you can see here are 2 plots with the x value going across. And I'm going to do something similar. And by the way, so you can just, if you look at it, you can see the grid on there. That's all that is. Easier to spot the data going across. We're going to take the same data for axis 1. So we have our plot of x squared, x and x cubed, line width 2. And this time we're going to take our axis 1 and do y limit. It's actually set underscore y limit. This is the y-axis, so it's going to be an array of two values. And we'll do 0, 60. I'm just making these numbers up. The guys in the back actually made them up. I'm just using their numbers. And we're going to set the x limit, and we'll set the x limit as, don't forget our brackets there, 2, 5. So it's the same data going in, but we're setting a limit on it. And let's go ahead and run that. And let's see what it comes out of. And here we have the y limit 0 to 60. So we're looking at just the lower part of this curve here up to here. And we have the x limit 2 to 5. So that starts right here at 2, and you can see very different graphs. This is kind of nice because you could actually put one of these on top of the other if you wanted to draw focus to one part of a graph. Remember how we did that earlier, one inside the other? But just a quick note, you can easily limit your graph and kind of reshape the way it looks quite easily. And we can also add that grid down there if you want a grid. We'll run that and add the grid in there. Whoops, I guess you have to do the grid beforehand. Switch that. There we go. Sometimes the order on this is really important, so you may double check your order when you're printing these things out. It also helps if I change it to 1. So in this case it might not be the order. I wonder if we'll go back here as 1. There we go. So it doesn't matter the order on grid. But you can set the grid for easy viewing here. Nice setup on there. But you can see how we can limit the data. So let's start looking at some other 2D graphs and make this cell a markdown. So when we run it, it has a nice pretty title to it. And let's go ahead and create some data with an NP array. We'll do 0 to 5 on here. There we go. And let's look at 4 common graphs. We'll put them side by side. So we'll do a figure. Our axes equals plot, subplots, 1, 4 columns, and then figure size. Hopefully it'll fit nicely on here. It seems to do pretty good on here. And I'll go ahead and just run that since we're in there. Run. You'll see I have 4 blank plots on here. And we'll start with axes of 0. Let's set title. and we want this to be a scatter plot. A scatter plot just means it has a bunch of dots on it. So here's our axes of 0 dot scatter. Easy to remember, scatter a bunch of plots on there. We'll do our n, or we can do x or n. There we go. And let's go ahead and do axes set title scatter. Oh, already did that. We're just going to do scatter. That's how you do it on there. That is how you create a scatter plot, simply with the scatter control. And we'll do, let's do the variable x plus, let's throw some randomness in here. Usually scatter plots are have a lot of random numbers connected to them. That's why they do them on there. And so the bigger the x gets, the bigger the randomness, so 0.25 times the randomness. And what we should end up down here is with the scatter plot. And you can see as you go up, it just kind of has some random numbers and moves up and down the line. But plots just the points. So if you remember from back up here where we did marker, this is plotting basically just the marker. So it's a scatter plot. Probably less used is a step plot. So for axes 1, we'll go ahead and do a step plot so you can see what that looks like. And this time I'll use our n value instead of x. We generated that n value up here. And so for this we have n times 2, our n squared, n times 2, n squared. Line width equals 2, and if we run that, it creates a nice step up. Let's see, so we've got a scatter plot, we've got a step plot. Let's do a bar plot. And we'll use the same formula, n squared, alignment centered, because you can have them to the left or right, width 0.5, and alpha, if you remember correctly, that's how opaque it is. Let's see what that looks like on there. So we have some nice, you can see here a nice bar plot. It should look very similar to the step plot, but colored in. And we can change the width. Let's see what happens when we do 0.9, run. And if we take width out completely, run that, you can see it starts coming together on there. And we can change the alpha. We can take the alpha out too and run that. So now you have the solid colors. And if we take out the center and run that, everything, you really can't see the shift on here because that's actually the default on this. But these are common settings for the bar graph. Let me just put them back in there. There we go. Alignment, center, and alpha. Now, I can't say I've used the step graph very much. There's certain, I guess, domains of expertise that require a step graph. But the scatter plot and the bar graph, very common, especially the bar graph. And we'll look at histograms here in just a minute. So I use histograms a lot, especially in data science. But this is nice if you have very concrete objects. How many people are wearing yellow hats? That kind of thing. But if we're going to do that, let's go ahead and do the last one, which I see a lot more in the sciences. I'm certainly using the data science, but more like for mapping. I saw a publication on solar flares, and they were discussing the energy. And so filling in the graph gives it a very different look. So we're going to do the fill between. And it's just like you think it'd be. It's fill between, but with a underscore between them. And we'll do x and x squared and x cubed. And we'll do color green and alpha again, in case you had other data you wanted to plot on there. You can see it forms a nice squared coming up here. And also, if you look at the bottom one is your squared value, the upper line is your cubed value, and then it fills in everything in between. If you remember from calculus, this would be if you had like a motor and efficiency, they would talk about the efficiency going up and the loss, and you're looking for the space or the area between the two lines. So it gives you a nice visual of that. And let's look at a few more basic two-dimensionals. So we're going to have our figure size on here. We're going to do a radar chart. To be honest, I've never used a radar chart in business or in data science. I have to find a reason to use one now. So the first line for doing a radar chart, we have to add axes into the figure. And with this actually creates our, let's run it so you can see what it creates. It creates a nice, looks like you're on a submarine and you're tracking the hunt for red October or something like that. And it needs all of these. The polar is the fact that we're doing polar coordinates. 0, 0, 0.6 has to do with the size. If you take out any of these things and run them, you get just a box. If you take out the other half, you pretty much get nothing in there. And if you change these numbers, change them a little bit, you can see it gets bigger. They had 0.6 on here. I'll go ahead and leave it as 1 because that's just kind of fun. But that's all about the size on here, the height and the width. And then let's create some data. T equals NP line space. And this is 0 to 2 times NP times pi. So if you remember, that is the distance across, and we're going to generate 100 points. So this is just a thing of data we're putting together. Then we can simply do an ax.plot, and in this case let's do t comma t, which would be a diagonal line on a regular chart, and we'll give it a nice color equals blue, and line width equals 3. Let's see what that looks like. And we can see here a spiral coming out. And remember, this would be just a diagonal line on a regular chart. What happens if we take this and instead of t times 0.5, there we go. And you can see it slightly alters the way it spirals out. We could do t times 2. Spirals out a little quicker. So it's kind of just a fun. Like I said, I've never used a radar chart. It's a column. But you can always think of radar in a submarine. Kind of looks like one of those, or in an airplane. And none of this would be complete if we didn't discuss histograms. Oh my gosh, do I use a histogram so much. And we'll use our numpy that we have set as np to generate, it looks like we have 100,000 variables we're going to set equal to n. And of course we create our figure and our axes, subplots 1, 2, figure size 12, 14. So we're going to look at 2 different variations of the histogram. And we'll set a title, default histogram, set our title there. And then this is simply hist for histogram, and we'll just go ahead and put in our n in there, and let me run this so you can see what that looks like. And let's talk about what is going on here. So we generated an array here of data, 1,000 random arrays. It looks like they're mostly between -4 and 4, and then it adds up each one. It says 0, you have 35,000 that are 0, so that's what's most common on here. And we have 20,000 that are somewhere in this range right here between the -2 and, well, it looks like 1 and -2. And somewhere between 0 and 1, there's 30,000 numbers. So all this is saying is this is how common these variables are. And this will point you in so many directions when you're looking at data science to go ahead and run your histogram. So you should always have your histogram, and you can always put limits and all the other different things on your array, just like you did on the other graphs on there. And then we're going to do a cumulative detailed histogram. And all it is a histogram. Let me just do that. And we set cumulative equal to true and bins equal 50. And I really want to highlight the cumulative equals true is important, but we can now choose how many bins we have. In the first one, it kind of selected them for us. In this case, let me go ahead and run this, and you'll see it prints the data out for us. And here's our, whoops, must have missed, there we go. It doesn't help that I put it over the old one. There we go, okay. So now you have your default histogram, and then we have a cumulative histogram, and we should have 50 steps in there. And let's just find out if that's true, not so much by counting them. I'm not going to count them. If you want to, you can count them. Let's just change it to 10 and see what happens. And we see here we have now 10 counts of that. And we could set that for 5 and run that. And then we have our 5 on there. And we go ahead and take the cumulative equals true out, just so you can see what that looks like. And let me run that on here too. That looks just like it did before. I think there's 1, 2, 3, 4, 5, 6, 7, 8. They have 8 different bins on here, is what the default came out of. Put that back in there, run. And so now it should look almost identical, and it does. And then we can put the cumulative back in, see what that looks like with the cumulative. And run that. And we can see how that shifts everything over and has a slightly different look. Wait, it shifts it all to the right? No, it doesn't actually shift it to the right. It's cumulative, so it's the total of the different occurrences. And so what that means is, like, if you consider this like for the year of rainfall, we have like day 1, you had a little bit of rain. Day 2, we have more rain. And so if you look at the number, this is 100,000, 35,000. So it's a cumulative detail, the histogram, the occurrence as it grows. And rainfall is a good one, because that would be a cumulative histogram of how much rain occurred throughout the year. And we're going to look at 2 more graphs. We've already looked at a bunch of them. We looked at our radar graph. We've looked at scatter, step, bar, fill in, basic plots. We've looked at different ways of showing the data. We can increase the size of the line, the look, the color, the alpha setting. So let's look at contour maps. Just put that in there. There we go. Draw a contour map. And before we draw a contour map, we need to go ahead and create data for it. And if you have contours, your data is all going to have 3 different values. So let's go ahead and create the data here. We have our, you'd import your Matplotlib library, your numpy, so we have our numbers array. And we'll import matplot.cm, and that's your color maps. So you have all these different color maps you can look at. there's like hundreds of color maps. So if you don't want to do your own color, you can even do your own color map. They're pretty diverse. And of course our PLT, our pie plot. And to generate our different data, we're going to create a delta 0.025, and we'll start with X. And we're going to create an array between -3 and 3 in delta increments of 0.025. And we'll have our Y, we'll do something similar, and then we'll create our XY into a mesh grid. Again, these are all NumPy commands, so if you're not familiar with these, you'll want to go back and review our NumPy tutorial. And we'll do an exponential on here, -x² minus y² for our z1. We'll do a z2, so we have two different areas, and z equals z of 1 minus z2 times 2. So we've created a number of values here. And let me go ahead and run this, and let's plug that in so you can see where those values are going. So once we've set these, we're going to create our figure and our x from our PLT subplots. We're going to create the variable CS. And this is going to be our contour. So right here, CS is our contour surface. And we're feeding it X, Y, and Z. And if you remember, X, Y we created as our X and Y components using our mesh grid. And you know what? Let's do this. Just because it's kind of good to see this. Let's go ahead and print X. And let's print Y. And I always like to do this when I'm working with something that's either is really complicated, in this case is what we're looking at, or you don't understand yet. So we've created a mesh grid, and we have X, Y, and when we're done with this, we end up with, here's our X, and this set of values, and our Y, so these are X and Y coordinates. And then we've also created Z based on our X and Y. So we have X, capital Y, and capital Z as our three components. X and Y being the coordinates, while Z is going to be our actual height, since we're doing a contour map. So we created our contour map from our X, Y, and Z coordinates. We want to go ahead and put in a C label. Maybe we want to go ahead and do a title on here. We'll put that in our set title, and this is a contour. There we go, contour map. And let's go ahead and run this and see what that looks like. And you'll see we generated a nice little contour map. There's different settings you can play with on this, but you can picture this being you're on a mountain climb, and here we have a line that represents 0, maybe that's sea level, and then moving on up you have your contours of 0.5 and then -1 and different setups, little hills. I guess if it's minus, that's like a pit. So I guess you're going down into a pit at -5 and -1. And on the other side, you can see you're going up in levels. So here's a mountaintop, and here's like a basin of some kind. And in data science, this could represent a lot of things. This could also be representing two different values and maybe profits and loss. I don't know if I'd ever really do that as a contour map, but I'm sure you can be creative and find something fun to do with a contour map. And then we're going to look at one last map, which is the 3D map. And those can be really important as a final product because they can show so much additional information that you can't fit on two-dimensional graphs. There we go. Draw a 3D image. And so we're going to import from our MPL toolkits the mplot 3D and the axes 3D. We're going to import axes 3D. This is what's going to let us work with the 3D image. And this should look familiar. We're going to create another figure just like we did before. Figure size 14 by 6. That's a good fit on the screen. We'll go ahead and run that. So we have our figure, and let's go ahead and take our x, and we're going to set that equal to fig.add subplot. That should also be familiar from earlier. And we're going to work with, this sets the settings for the projection. And we're going to use 1, 2, 1 projection 3D. And we'll see what that looks like in just a minute. And we just created some three-dimensional data here before, where we had X, Y, and Z, capital X, Y, and Z. So we're going to reuse that data. We're just going to use that since this is also a three-dimensional image. So let's use that for a three-dimensional graph. And we simply do AX plot underscore surface, and our capital X, capital Y, capital Z. So there's our data coming in. And we're going to add some settings in here. We're going to do R stride 4, C stride 4, and line width 0. And I'll show you what that is here in just a minute. Let's go ahead and run that so we can see our graph. And of course it helps if I don't add an extra comma in there. And you can see it generates this really beautiful three-dimensional graph. So let's take a little bit time to explore some of these numbers we have going in here. We have the R stride 4, the C stride 4, and the projection 3D. Projection 3D is the important one because that's telling us that this is a 3D graph here. So what are these first numbers? 1, 2, 1. Let's just change one of these. I'm going to change this to 5. and it's going to give me an error. Let's change it to 1. And that didn't work. Let's change this middle one to 3 instead. And you're going to see how it starts reshaping the size and how it fits on the screen. And we'll change the first one to 2. We'll run that one. And again, it's changed the dimensions and the size and how it fits on here. Play with these numbers so you get a nice look and feel for it. Part of it is the tilt and the angle. We'll do 7 on this one. There we go. You can see it really shifted it there. But again, that changes the size and how it fits on the canvas. But we'll leave it at the 1, 2. And just so you get a good look at what we're talking about here, this is column width and index from before. If we do 1, 1, 1, you can see that it now spreads it out all the way across. It uses the whole setup on there. So this has to do with the size and how big you want it to be. Now, there's one term that we didn't cover in this yet, but we've used it throughout the whole setup. And I'm just going to type that down here, even though we're not going to go into detail. And that's the term heat map. You might see that is kind of starting to lose ground as far as a common reference, but there sure are a lot of people who still talk about heat maps. What is a heat map? Well, it is simply a color map. That's all it is. So if you ever see the term heat map, that refers to the fact this is in different colors representing different heights. That one isn't a heat map, but you can see up here we switched into, let me go back up here, here we go. This one has different colors for the different values. A lot of times you'll use, like instead of X and Y, you might do a heat map where you have a 4th value, and the 4th value represents the color. And so you'll see this 3D image in a nice colors represented by a heat map. That's all it is. So if you see the term heat map, that only means we're plotting some of the data in color to make it stand out or to give it a 4th dimension in this case. So we've covered a lot of things on Matplot, and that brings us, covered all the basics, so that brings us to practice example. And this is going to be the challenge for you. And let me go ahead and change our cell type markdown and run that so it looks pretty. Practice example, write a Python program to create a pie chart of the popularity of programming languages. Okay, excellent. And if you're going to have a challenge, we need some data. And I'll just throw in import our Matplot library at the beginning. You should do that automatically. And so for our data to plot, we're going to have our languages. We're going to have Python, we're going to have Java, PHP, JavaScript, C#, C++. So those are 6 categories. And then we have our popularity. Oops, misspelling there. Popularity. We'll give the first one 22.2%, Java 17.6%. And I don't know if these are real numbers they pulled. My guess is that they might have just been made up because I don't know if Python's really that much more popular than the other ones. Maybe specific to data science, because Python's very popular in data science right now because it has so many options. The only other program that's highly used and exclusively for data science is R. So Python's big, and Python also does a lot more. It's a full programming language, where R is primarily for data science. They didn't even put R in here. So we have Python, we have Java, we have our PHP, and you can see the different values they've given it, or different percentages. And I did add these up. It does not add up to 100%. It adds up to 71% or something like that. And then we're going to give colors. And we've chosen, these guys in the back brought in these colors. I'm not sure what these colors are. We'll find out in a minute, so it'll be exciting. But you can see they're using the actual color values you can pull off of a color wheel or something like that. You could have just as easily done blue, red, green if you're too lazy to pick the exact colors. And then let's go ahead and solve this and see what we got here. We're going to do something a little fancy just because we can. The first thing we're going to do is we're going to use a variable called explode. And you'll notice that there's 6 variables in here, so that matches our 6 different categories. And the first one we've done is 0.1 and then 0, 0, 0, 0, 0. 0.1, when we put this in here under the explode in the plot, it will actually push that square out. So it's a really cool feature to highlight certain information on a pie chart. And this is simply plt.py. And we're plotting popularity. There we go. And before we add in all the really cool settings for this, let's go ahead and run it. And you'll see we generate a nice flat pie. Not too exciting there. And then we'll go ahead and put in all the extras. I talked about explode, where we can explode one of the values out. So here's our explode equals explode. Labels is languages, because we want to know what the different colors mean. Here's our colors equals colors, our auto picture. And this is standard print format. So that's a Python setup on there. And that's just going to put the value on the pie slice. And then we're going to add shadow because it just looks cooler with a shadow. Gives it a little 3D look. And we'll do a start angle of 140. Let's go ahead and run this and take a look and see what comes out of that. And look how that changes the whole setup. So here's our labels. There's our value we put on there. There's our slice that's pushed out. There's our shadow, a 3D effect. And then we started at 140. We could also rotate this. Let's just do this angle 90. And if we run it, you'll see the blue pie slice has moved up a little bit. We could actually let's just take the whole starting triangle out and run. It'll default to 0. And this is what it looks like if it defaulted to 0. So depending on where you want the highlighted slice to appear, usually you want that to appear on the left because people read left to right. And so it draws a focus onto, in this case, Python and how great Python is. I'm a little biased. We're teaching a Python tutorial, so it should be understandable that we're looking at Python. And one last reference before we close, you can go over to the matplotlib.pyplot setup, and if you go underneath the different functions on there, you can look this up on their website, you'll see a full list, and this is why it's so important to go through a tutorial like this, because this list is just so massive. I'm trying to figure out, like, here's our bar plot, there's a bar H, you can add barbs, there's a box plot we didn't cover, C labels, a totally different kind of, for your contour plot you can set up in there. If you go down here, we have our figures we used on there. We showed you the basics of how to do the figure. You'll see some closer references on those. There's a histogram down here, HIST. There's also the hist2d, makes a 2D histogram plot. H-lines, all of this, these are all the different commands that are underneath of here. And you can see it's pretty extensive. We've covered all the basic ones so that you now have a solid ground to look at these different options. So when you come to these functions, some of them are going to look a little off, or not off, will look unfamiliar, but you'll still have the availability to probably understand most of this and have a basic understanding of your Matplotlib library.
We will learn how to visualize data and draw insights with different charts and graphs using the Seaborn library. These visualizations are often referred to as plots in Python. So what is Seaborn in Python? The Seaborn library in Python is a widely popular data visualization library that is commonly used for data science and machine learning tasks. It is built on top of the Matplotlib data visualization library and allows you to perform exploratory data analysis. Using Seaborn, you can create interactive plots to answer specific questions about your data. It helps you find trends in your data that you can't notice just by looking at the data. Now, to understand the Seaborn library in detail and how to create different plots and know the data better, we will be using two datasets in our demo. The first one is the empty cars dataset and the second is the popular iris flower dataset. Now let's head over to our Jupyter notebook and start with our demonstration. So I am on my Jupyter notebook. Let me go ahead and rename the notebook. I'll say Seaborn demo. We'll rename it. Alright. You can see I have the first two cells already filled in. So while working on an exploratory data analysis project using Python, you will need NumPy, Pandas, Matplotlib and Seaborn libraries for data manipulation and visualization. So let's import these libraries first. So I've already written import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT, Seaborn as SNS. Alright. So I'll hit Shift Enter to run this first cell. Alright. Now, using the read_CSV function that is present in the Pandas library, I am importing my dataset, that is empty cars. I'll tell you what empty cars is about. This is a CSV dataset and here I have given the location where my dataset is present. Let's run it. Alright. Now, let me go ahead and print the first 5 rows of my empty cars data frame. For that I'm using the head function. If I run it, okay, you can see here it has given me the first 5 rows. The index starts from 0 till 4, so total 5 rows of information, and you can see these are the columns that are present in the empty cars dataset. The first is the model of the car. Now just let me give you a background about this dataset. So the data is taken from the 1974 Motor Trend US magazine. It has information about fuel consumption and 11 different aspects of automobile design and performance of 32 cars. Alright, so here we have the first column as the model of the car, and then we have MPG, which is miles per gallon. Then we have CYL, which stands for the number of cylinders in the vehicle or the car. Then we have DISP, which is displacement in cubic inches. So these all values are in cubic inches. After that we have HP, which is gross horsepower. Then we have something called as DRAT, which is basically the rear axle ratio. Then we have WT, which is the weight of the car in pounds. So think of it as weight multiplied by 1000 pounds. Alright, and then we have Cursec, which is 1/4 mile time. This is a measure for acceleration. Then we have something called as VS. This is the type of engine for each of the vehicles. So 0 stands for V-shaped engine and 1 stands for straight engine. Then we have AM, which is basically the mode of transmission. So 0 is for automatic transmission and 1 is for manual transmission. Then we have the number of forward gears present in the vehicle, and then we have something called as CARB or CARB. This stands for the number of carburetors. So carburetors is a device for supplying a spark ignition engine with a mixture of fuel and air. Alright, now we'll use the info function to print the summary of the data frame. So the info function returns information regarding the index data type, column data types. Then we have the information about non-null values and memory usage. So I'll write my data frame name, which is empty cars dot, I'm going to use the info function. Let's run it, and here you can see we have all the columns. There are total 32 entries from 0 to 31, so data about 32 cars. Then here you can see the data types and the memory usage. Now moving ahead, let me just print the shape of the data frame. That will give you the number of rows and columns present. I'll use the shape attribute. You can see here there are total 32 rows and 12 columns in my data set. Now the Seaborn library provides a range of plotting functions that makes the visualization and analysis of data easier. So we'll cover some of the crucial plots that are available in Seaborn. So let's start with a bar plot. I'll give a comment as bar plot. Now first understand what a bar plot is. So a bar plot gives an estimate of the central tendency of a numeric variable with the height of each rectangle. It provides some indication of the uncertainty around the estimate using error bars. Now to build this plot, you usually choose a categorical column in the x-axis and a numeric column on the y-axis. So we'll create a bar plot between the number of cylinders and the miles per gallon. So let's start. I'll declare a variable called res, which essentially stands for result. Then I'll use SNS, which is for the Seaborn library. I'll say SNS dot followed by my bar plot function, and inside the function I'll pass in my data frame name, that is empty cars, and then for x-axis within the bracket using quotation I'll give my column name as cylinder. So this is going to be my x-axis, and for y-axis I'll say my data frame name empty cars, then the square bracket followed by my y-axis column, that is miles per gallon. Now to display I'm going to use the Matplotlib function. I'll say plt.show. Let's run it and we'll see the result. There you go. So here you can see on the x-axis we have the number of cylinders. So in our data we have vehicles with 4, 6 or 8 cylinders, and on the y-axis you can see the miles per gallon. Now what essentially this graph tells us is that when the number of cylinders in the vehicle increases, my miles per gallon on MPG for the vehicles decreases. And you can see these black lines. So these lines indicate the uncertainty around the estimate using error bars. Alright. Now you can create the same bar plot using another way. Now we will exclusively define the x and y axis columns and also pass the name of the data frame using the data argument. Let me show you how to do it. I'll use the same variable name res, which stands for result. I'll say sns dot bar plot. Now inside the bar plot function, I'm going to exclusively define my x axis. I'll say x equal to, I'll pass in my column as cylinder. Then I'll say y axis, which is miles per gallon, and then using the data attribute I'll pass in my data frame name, that is empty cars. And finally we'll write plt.show. Let me run it. You see here we have the exact same bar plot as the above one. So this is another way to create a bar plot. Now Python Seaborn allows the users to assign colors to the bars. So the bar chart that we are going to create will convert all the bars to a particular color. So for that I am going to use the color argument. So I'll say res equal to sns dot my function, that is bar plot. I'll say x equal to cylinder. My y axis will have mpg, and then I'll say data is empty cars, give a comma, and my final attribute I'll say color equal to, I'll say yellow. Close the bracket, and then I'm going to write plt.show. If I run it, you can see here all the bars have been converted to yellow color now. You can change the color argument. Let's say I'll make it to red. If I print it, you can see here all the bars have been changed to red color now. Alright. Now Seaborn library also has the palette argument, which you can use to give different colors to the bars. So if you go to Google and search for Seaborn palette, you have a nice link here. So here you have, there are different palettes provided by Seaborn. You can see here sns.color palette, and these are the names of the palette. You can use whichever palette you want. Alright. So I'll say res equal to sns.bar plot. We'll use our first method of assigning a bar plot. So I'm using my data frame empty cars, and this time we are going to change the x and y labels. Let's say I'm using my x label as transmission, whether automatic or manual transmission, and then in my y axis I'll have miles per gallon. Then I'm going to say palette equal to, I made a spelling mistake here. Let's say our palette is set2. This is the name of the palette. I'll write plt.show. If I run it, you can see here we have the two modes of transmission. 0 is for automatic transmission of the vehicle, 1 is for manual transmission, and you can see the miles per gallon for each of the modes of transmission. If you want, you can change the palette colors. Let me just copy this. I'll paste it in my new cell, and instead of set2, let's say we'll use another palette called as rocket, and I'm also going to alter my X and Y labels. Let's say in my X label I'll have gear and my Y label will be horsepower. If I run it, you see here we now have a different palette and the bars are of different colors. On the X-axis you have the gears, 3 gear, 4 gear or 5 gear vehicle, and on the Y-axis you have the horsepower. So from the graph you can see the horsepower is low for vehicles that have 4 gears, while it is high for the vehicles that have 5 gears. Now let's understand how to create a count plot. So the count plot function in the Python Seaborn library returns the count of total values for each category using bars. We will create a count plot that returns the total number of vehicles for each category of cylinders. I'll just give a comment here as count plot. Alright, so I'll start SNS dot, I'll use the count plot function and I'll define my X-axis as cylinders. My Y-axis won't have any label or any column because Y-axis will only show the count. Then I'm going to use my data parameter or the argument and pass in my data frame name, that is empty cars. Let's say I'll set the palette to set1. Let me run it. Okay, there is some error. Let's debug the error. It says str object has no attribute get. Okay, so this should be without the single quotes. Make sure the data frame name is without the single quotes. Let's run it again. There you go. So you can see here this is a nice count plot that shows the number of cylinders on the X-axis, and on the Y-axis you have the count. You can see here there are more number of vehicles that have 8 cylinders and there are less number of vehicles or cars that have 6 cylinders, and actually you can count it as well. So you can see here there are 14 cars that have 8 cylinders, there are 11 cars that have 4 cylinders, and there are 7 cars that have 6 cylinders. Alright, now moving ahead, the next count plot will show the number of cars for each carburetor. So for that I'm going to say SNS dot count plot. My X-axis will now have the variable carburetor. I'll say data equal to empty cars, and my palette I'll set it to set1, or let's say set2. Now let me run it. You can see it here. On the X-axis we have the different number of carburetors, 1, 2, 3, 4, 6 and 8, and you can see we have more number of cars that have 2 and 4 carburetors, and there are very few vehicles that have 6 and 8 carburetor. Cool. Now moving ahead, so the Python Seaborn library allows you to create horizontal count plots where the feature column is on the Y-axis and the count is on the X-axis. Let me show you how to create a horizontal count plot. I'll say SNS dot count plot. I'm going to define my Y label or the Y-axis as gear. I'll say data equal to empty cars and set my palette to, let's say, rocket. Let me run it. Okay, you see here this is a horizontal count plot, if you compare it with the above one, these were all vertical count plot, as in the bars were vertically aligned, but here you can see the bars are all horizontally aligned, and on the y-axis you have the gear column, and on the x-axis you have the count. So if you mark here properly, you can see there are 15 vehicles with 3 gears, there are 12 vehicles that have 4 gears, and there are total 5 vehicles with 5 gear. Now you can also create a grouped count plot using the hue parameter. So the hue parameter accepts the column name for color encoding. Now let's build a count plot that shows the number of cars for each category of gears grouped by the number of cylinders. So we are going to group based on the number of cylinders. Let me show you how to use the hue parameter for that. I'll say sns.countPlot. In the x-axis I'll have my gear column. Then I am going to pass my hue parameter that will have the cylinder column or the number of cylinders for each vehicle. I'll pass my data frame using the data argument as empty cars and say palette. I'll set my palette to set1. Let's run it. If I scroll down, you see here we have a count plot. On the x-axis you have 3, 4 and 5 gears of the different vehicles, and for each gear you have the bars that represent the number of cylinders. So for vehicles that have 3 gears, we have majority of the vehicles having 8 cylinders. Similarly, for vehicles that have 4 gears, we have most of the vehicles with 4 cylinders. And if you compare for the cars that have 5 gears, so we have equal number of vehicles that have 4 and 8 cylinders, and then we have one vehicle that has 6 cylinders. Cool. Now moving ahead. So the Seaborn library supports the distplot function that creates the distribution of any continuous data. Let's create the distribution of miles per gallon of the different vehicles or the cars. The MPG matrix measures the total distance the car can travel per gallon of fuel. So here I'll give a comment as distplot, which stands for distribution plot. I'll say sns.distplot. I'll pass in my data frame name, that is empty cars, give a period and say mpg, which is my column name. Then I'm going to define the number of bins that I want, let's say 10, and then I'll use the color argument and I'll say, let's say G, which is for green. Let's run it now. There you go. If I scroll down, you can see we have a nice distribution plot. So these are all histograms, and you can see we have a smoothed curve, and this shows the distribution of miles per gallon that is present in our dataset. Alright, now moving ahead, you can also create heat maps using the Seaborn library. So the heat maps will let you visualize matrix-like data. The values of the variables are contained in a matrix and are represented as colors. You can create a correlation heat map, which is a graphical representation of a correlation matrix representing the correlation between different variables. So in our example, we will create a heat map where you can find the correlation between each variable in the empty cars dataset. I'll just give a comment as heat map. I'll say SNS and I'll use the heat map function. I'll pass in my data frame name, that is empty cars, followed by my function called CORR, which is for correlation. Then I'll say C bar is equal to true. So the C bar argument is used to draw the color bar. Then I'll say line widths I'll pass it as 0.5. Let's run it. There you go. Here you can see we have a nice heat map, and on the right side you can see the color bar that starts from minus 0.8 and goes up to plus 0.8. So this ranges between -1 and +1, and the bars or the cube you can say that have a lighter color have a positive correlation, and the ones that are dark have a negative correlation. So for example, you can see here for cylinder and MPG the color is really dark, which is around this region -0.8. This means when the number of cylinders in the car increases, your miles per gallon decreases, and this we also had seen in our first bar plot. This one you can see here, whenever the number of cylinders increased, your miles per gallon had decreased, and this is what has been depicted in our correlation map or the heat map. But if you see for cylinder and displacement, there is a positive correlation which comes around this color bar range. Similarly, there are other features in the dataset. For example, if you compare for the weight of the vehicle and the number of cylinders, there is a positive correlation, which means when the weight of the vehicle increases, the number of cylinders present in the vehicle also increases. And the others you can also compare and find out the correlation based on this color bar.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, now let's move ahead. The Seaborn scatterplot function helps you create plots that can draw relationships between two continuous variables. So to understand about scatterplots and other plotting functions, henceforth we are going to use iris_flower dataset. So let's go ahead and load the iris_flower dataset. I'll say iris equal to sns.load_dataset. So this iris_flower dataset is already inbuilt into the SNS or the Seaborn library. Now we'll go ahead and print the first 5 rows from the dataset. There you go. Here you can see here there are total 4 feature variables. You have the sepal length, sepal width, petal length and petal width of the 3 species of flower, that is Setosa, Virginica and versicolor. So using this dataset we are going to see the rest of the Seaborn plotting functions. First let me go ahead and print the different species of flower and the count for each of the species of flowers that we have in our dataset. I'll say iris, within square brackets I'll pass in the output or the target variable, that is species, and I'll use the function that is value_counts. Let's run it. There you go. So we have 50 flowers of Setosa type, again 50 flowers of versicolor species, and then we have another 50 flowers of type Virginica. So there are total 150 flowers present in our dataset. Alright. Now we'll create a scatter plot to show the relationship between sepal length and petal length for different species of iris flowers. So I'll say SNS dot followed by the scatterplot function. In the x-axis I'll say sepal length column, give a comma, I'll pass in my y-axis with petal length, then I'll say data equal to iris. Now let's run it. you can see here, this is my scatter plot between sepal length and petal length. Now you can classify the different species of flowers using the hue parameter as species in the function. So what I'll do is, I'm going to copy my above code. I'll just paste it here, and we are going to edit in this cell itself. I'll add a last parameter called hue, and this will have my species column. Let's run it and see the difference. There you go. Here you can see we have a nice scatter plot. The blue dots are for setosa, the orange dots are for versicolor, and for virginica you have the green dots. From this scatter plot you can see that for virginica flowers the sepal length and the petal length are higher than your versicolor and setosa, and this region is completely for setosa flowers. So you can say that the setosa flowers have lower sepal length and petal length. Alright, you can also use another parameter known as the size that will differentiate the different species of flower in terms of the size of the dots. I'll say size as species. Let's run it. You can see the result. There you go. So here you can see the virginica flowers are in green dots. The size is small, followed by versicolor with medium sized dots, and then we have setosa whose size is large. Okay. Now the Python Seaborn library lets you visualize data using pair plots that produces a matrix of relationship between each variable in the dataset. So let me show you how to create a pair plot. I'll say SNS dot pair plot, which is the function. Then I'll pass in my data frame name, that is iris. I'll put this iris data frame within double quotes and we'll run it. Okay, there is some error here. Let's debug the error. Data must be pandas data frame. Okay, what I'll do is I'll just remove the double quotes and we'll run it. This might take some time to create the pair plot, so just wait for a while. There you go. Here you can see we have a nice pair plot. On the y-axis you have the sepal length, sepal width, petal length and petal width. Similarly on the x-axis also you have the same feature columns. All the diagonal plots are histograms and the rest of the plots are scatter plots. Now you can convert the diagonal visuals to KDE or kernel density estimation plots and the rest of the scatter plots using the hue parameter. This makes the pair plot easier to classify each type of flower. So I'll just copy this cell of code, paste it here, and I'll say hue equal to species. Then I'll say palette equal to set1. Let's run it and we'll see the new pair plot now. This might take some time. There you go. So here you have the pair plot ready, and on the right side you can see the different species. The red color dots represent setosa flowers, the blue color dots represent versicolor, and the green color dots represent virginica flowers. Now if you look at this graph, you will find that your petal length is the best feature to classify the three different species of flowers. The reason being, you can see here they are very well categorized and they are separated. All the red dots present here in the petal length represent setosa flowers. Around this range, all the blue dots represent versicolor flowers, and the green dots are all virginica flowers. So out of the 4 features, petal width, petal length, sepal width and sepal length, you can take petal length as the best feature to differentiate between the 3 species of flowers. Alright, now coming to lmplot function. So the lmplot function in the Seaborn library draws a linear relationship as determined through regression for continuous variables. So let's create the plot to show the relationship between petal length and petal width of the different species of iris flowers. I'll just give a comment here as lmplot. I'll say sns dot lmplot. In the x-axis we'll have petal length, give a comma. In the y-axis I'll pass in petal width, and I'll pass in my data frame using the data argument or parameter, which is iris. Let's run it. You can see it here. We have a nice plot. The line you see here is a linear regression line. Now in this lmplot, you can use the hue parameter to differentiate between each species of flowers, and you can set markers for different species. Let me show you how to do it. I'll say sns dot lmplot. We'll say x as our petal length, give a comma. I'll write y as petal width. Then I'm going to pass the hue parameter. In hue I'll say my column as species. Then I'll give data equal to my dataset name, that is iris. And now you can pass in markers argument to differentiate the different types of flowers. Let's say I want to represent setosa with dot or O. Then my next species, which is versicolor, should be represented with a star symbol, and the final virginica species of flowers should be represented with, let's say, this arrow mark. Now let me go ahead and run it. There you go. You have 3 different linear regression lines, and the circle dots in blue color represent setosa, the orange color stars represent versicolor flowers, and the triangles represent virginica flowers. So this is how you create a linear relationship between the different types of flowers using the regression line. Alright, now let's take a look at the final plotting function, where we will create a box plot. A box plot, also known as a box and whisker plot, depicts the distribution of quantitative data. The box represents the quartiles of the dataset. The whiskers show the rest of the distribution except for the outliers. Now let's see the distribution of the 3 species of flowers based on their sepal width. I'll just give a comment as box plot. Is the final plot that we are going to see in our Seaborn demo. I'll say sns dot box plot. In the x-axis we'll have the species column. In the y-axis we'll have sepal width. Then I'll pass my data as iris. Let's run it. There you go. we have this box plot created. At the bottom in the x-axis you can see we have the box plot for setosa flowers, orange for versicolor flowers and green for virginica flowers. Now this line represents median, which is inside the box. So this is also the median for versicolor flowers. You can compare the median sepal width for each of the flowers from the y-axis. This line represents the maximum sepal width value for setosa flower, and this line at the bottom represents the minimum length of the sepal width for setosa flowers. Now these dots that you see outside the box plot are called as outliers. The extended lines that are outside the box plot are known as whiskers. Alright, so that brings us to the end of this demo session on Seaborn library in Python. So first we imported our empty cars dataset. Then we saw how to create a bar plot. We learned how to use the color argument or the parameter inside bar plot. We also saw how to use the palette attribute or the palette parameter. Then we learned about creating count plots. Then we saw how to create horizontal count plot. Now moving ahead, we saw how to create distribution plot. Then we saw a correlation heat map. After that, we analyzed the other functions such as the scatter plot. Then we had the pair plot, and we had the LM plot for finding the linear relationship, and later we saw the box plot using the iris flower dataset.
Before we dive into this video, let's get a basic overview of what you can expect to learn from this video. What's in it for you? So first, we will explain what exactly the meaning of bokeh is. Then, we will take a look at scatter charts and see how we can implement them in bokeh. Next, we'll understand what line charts are, the scenarios in which they are used, and how they can be coded in Python bokeh. Then we'll move on to pie charts and understand how data distribution can be represented using them. Next, we will take a look at histograms. Then we'll move on to bar plot and understand the difference between histograms and bar plots. We'll then take a look at area plot and how to understand them. And then we will move on to the layout function in bokeh, which is used to make interactive web pages. And finally, we will use a data set to understand how we can make interactive charts in bokeh by using everything that we've already learned in this video. So the first question that probably comes to your mind is, what exactly is bokeh? Bokeh is a Python library which is used to make highly interactive graphs and visualizations. This is done in bokeh using HTML and JavaScript. This makes bokeh a powerful tool for creating projects, custom charts, and web design-based applications. Now, Bokeh is a Python library for creating interactive visualizations for modern web browsers. It helps you build beautiful graphics ranging from simple plots to complex dashboards with streaming datasets. With Bokeh, you can create JavaScript-powered visualizations without writing any JavaScript yourself. This makes it a very powerful tool for data visualization. Next, let's take a look at scatter charts and how you can plot them in Bokeh. Now, scatter plots are a plot of each individual data point in the data. Two variables are plotted against one another, and each data point on the x-axis has a corresponding individually plotted value on the y-axis. As a result, the plot looks like a bunch of scattered points. These are some examples of scatter charts. Here, each point on the chart corresponds to a value on the x-axis and its respective value on the y-axis. Using scatter plots, we can see how two different variables correspond to each other. Now, let's see how we can plot scatter charts using Bokeh. So the first thing that we're going to be doing is importing all of the necessary modules for our Python project. The first module that we're going to need is the pandas module, which is used to work on data frames. Next, we will also be importing the pandas bokeh module, which is used to implement bokeh on pandas data frames. Next, we will import bokeh.io, which we will use to show the various graphs that we are plotting. We will also import bokeh.plotting, which will help us in plotting all of the various graphs that we're going to be looking at. We'll also import glob, a module which will help us merge our files and get them in the required format. So the first line of code that we're going to be writing is pandas_bokeh.output_notebook. This is basically just a line of code which will help you see your output in the same notebook itself. Now let's see how we can plot scatter plots in Bokeh. We already have imported the figure function from bokeh.plotting. The figure function contains most of the plots that we want to plot, such as line plots, scatter plots, bar charts, etc. So this is what we're going to be using. The first thing that you're going to need to do is create a figure. So how do we do that? Let's create a random variable p, and this we're going to be initializing to the figure function. Now within this figure function, we're just going to add a couple of parameters for our figure itself. So let's say we want the plot width to be equal to 400 and the plot height to be equal to 402. We're going to be plotting a scatter plot in the form of a square here. Next, we know that a scatter plot is nothing but various circles which are plotted on top of our graph. So that's what we're going to do. We're going to be plotting circles at certain coordinates which are going to be given by our lists. So the first coordinate is going to be the x-axis, and the next list that you're passing in is going to represent the y-axis coordinates. So over here, let's just plot this as 1, 2, 3, 4, and 5. And over here, let's start with 4, 7. These are all just random points. This is just to show you how exactly you can plot a graph in Bokeh. And now let's just say that we want the size of the circles to be equal to 10 and the color of every circle to be navy. We're also going to give a random parameter called alpha and equate that to 0.5. This will just act as a placeholder. Now over here, you've initialized your figure function and given it certain parameters. And using this figure function, you're calling the circle attribute of it, passing in other parameters such as the x-axis coordinates and the y-axis coordinates, the size of the circle, the color of each circle, and a random parameter called alpha. So now we've imported all of our modules. And this is how you plot a scatter chart in Bokeh. The same thing can be done when you look at the line plot. All you have to do is initialize your figure function and call the line attribute of it, pass in your x-axis coordinates and your y-axis coordinates, maybe pass in a couple of other parameters that are required, such as the width that you want the line to be and the color that you want the line to be, and finally all you have to do is show the plot. This is a basic overview of how you can use Bokeh to plot graphs. And here we have a line plot. So the main difference between the scatter plot here and the line plot here is that the line plot has various different points which are connected to each other with the help of a line. So again, what exactly are line charts? A line chart is a chart that represents data as a series of points which are connected to each other with the help of a line. It is used to see trends in our data and track the way data changes over a period of time. So this is the same chart that we just plotted using Bokeh right now. So as you can see, so the parameters that you know were passed in were 1, 2, 3, 4, and 5 on the x-axis, and 3, 1, 2, 6, and 5 on the y-axis. So how exactly the line chart is plotted is that you plot each of these points and then you connect them or join them using a line. Next, let's take a look at pie charts and how they can be implemented in Bokeh. But first, what exactly is a pie chart? A pie chart is a circular chart which is divided into slices to represent how much of the data belongs to a certain category. It is a quick and easy way to see the categories in our data and the percentage of the data set that they represent. On the other hand, you have another type of chart called a donut chart. Donut charts are like pie charts with a hole in the center. And in this hole, you can use it to represent extra data, or you can draw a pie chart within that hole itself. So this is an example of a pie chart. Using this, you can easily get to know the various categories that our data is divided into and the percentage that each of these categories contribute towards our data. Like over here, we have a pie chart which represents crewmates and imposters in a game called Among Us. So using this, we can just say that around 75% of our data is crewmates and 25% of it is imposters. On the other hand, you have a donut chart, which is almost exactly the same as a pie chart, except the middle portion is missing values. And in this middle portion, you can do other things such as plot a pie chart or represent other data within it. So now let's see how we can plot our pie plots using Python Bokeh. But first, we need to import the data that we're going to be using to plot all of this. So the data that we're going to be looking at is the Among Us data. Among Us, as you might know, is a game that caused quite a frenzy in the past 2 years. So the data that we're going to be working at is the Among Us data set that you can find on Kaggle. Among Us was the new craze for people playing mobile games that suddenly exploded in popularity and became a hit video game during the pandemic. Now, Among Us is basically a multiplayer game where 4 to 10 players are dropped in an alien spaceship. Each player has their own role of imposter or crewmate. The task of the crewmate is to run around the spaceship to complete various tasks which are assigned to them and also to not get killed by an imposter. Players can be voted off the ship, so each game becomes one of survival. So let's load this data set and create more features. So now we've imported our data set. As you can see, our data set has over 2000 rows and 14 columns. The first column that I want to show you is the user ID column. The user ID column tells us which user the game data was collected from. Now there are 14 columns. The game completed data tells us the date and time of game completion. The team tells us if the player is an imposter or a crewmate. The outcome tells us if the game was won or lost. So over here, this is each game that a certain user has played. The user ID is used to represent the user who has played the game, and as you can see, we've collected data from 29 different people. And the number of games that these 29 people totally have played is over 2000. The outcome tells us whether the user has won or lost in this game. The task completed tells us how many tasks was completed by this user in this game. All tasks completed tells us whether the user was able to finish their tasks. Murdered tells us if the user was murdered. And imposter kills tells us the number of kills by the imposter. So if the user was not an imposter, we do not have data on how many kills was committed by the imposter during that particular game. That's why this column has a lot of missing values. Game length tells us the total duration of the game, and ejected tells us if the player was ejected or thrown off of the spaceship by their fellow players. Sabotage is fixed is basically the imposter within the game can create sabotages and it's the crewmate's duty to fix them. So this tells us the number of sabotages which was fixed by this particular crewmate. Time to complete all tasks tells us the duration taken by the crewmates to complete all the tasks, and the rank change tells us the change in rank after wins or losses of the game. The region or the game code tells us the server and the game code. Now first, let's just see how exactly the data is distributed. So this tells us how many counts each column has. So as you can see here, most of them have the same number of counts except rank change, which has a couple of missing values. Unique tells us how many unique values exist in each column. So obviously team, there will be 2 because there are only 2 possible outcomes. You can either be a crewmate or you can either be an imposter. Outcome also has only 2 unique values because you either win a game or you lose a game. Task completed has 12 different values, and this is because the number of tasks which have been completed probably range from 1 to 12. All tasks completed has 3 values, which is yes, no, and missing data. And the same goes for murdered. You have yes, no, or missing data. Imposter kills tells us how many kills the imposter has made. So in this case, the most kills that the person has made is probably 9. Game length, there are 988 different values, and ejected, again there are only 2 values because you can either be ejected or you can either stay in the game. Now the top value tells us the most frequently occurring value, and the frequency tells us the frequencies of all of the top values. Now let's create a feature called minute and extract data from game length. So we're going to be splitting the game length column, which is this column, and we're going to be converting it into minutes. And then we're going to be using that data and creating a separate feature column called minutes out of it. So let's do this. So these are the first top 2 values of our new minutes column. The 0th value is 7 because the first game length that you see here was of 7 minutes. So all that we're doing is that we're going to be splitting this value, which is 7 minutes 4 seconds, and we're going to be keeping only the first value, which is that of the minutes. The second minutes value is 16 minutes, and that corresponds to the second value in our minutes feature variable. Now let's take a look at the murdered column. The murdered column has yes no values and missing data set and missing values. So let's change those. We're going to be replacing no values with not murdered, yes values with murdered, and the simple dash with missing. And we're going to be doing this in place, which basically means that this is going to make a change to our main data frame. So this is done. Let's take a look at our data frame now. This is what our data frame looks like. We have a game's length column, we have a minutes column, and we also have made changes to our murdered column, which is represented here. So now we don't have any missing values or dashes in our murdered column. We have all of it represented as categorical data. And this is one of the main columns that we're going to be using to plot our pie plots. So now let's see how we can plot a pie chart. The first thing that we're going to be doing is that we're going to be getting the total value counts in our team column here. So we're going to be plotting a pie chart with the help of this team column, and we're going to be getting the value counts of each unique value in the team column. So you can do this with the help of the value counts function that Pandas data frames provides us with. And now that we have the value counts of each unique value which is present in our team column, let's plot it in the form of a pie chart. We're going to be doing this with the help of the plot bokeh function. And the type of chart that we want to plot is a pie chart. Let's give it a title as ratio of imposters versus crewmates, and let's run this now. And this is what your pie plot looks like after you've plotted it. So now the same thing can be done to plot a donut plot. The first thing that we want to see is if there are more crewmates or imposters murdered or not in the game. To do this, we will add two more features, angle and color, which are going to be used in the chart. So to get angle, we're going to be importing pi from math, and we're going to be converting our angle in the form of radians. And as for the color feature, we're going to be having 3 different shades of blue. So this is basically what our murdered data frame looks like. So over here you have not murdered, the total value counts of which is 894, and the angle that this gives us is 2.522302, and this is the corresponding color. The same goes for murdered, which is 867 values, and we've converted that into an angle in radians and given it its own color. And finally we also have missing values, of which there are 466. The angle is 1.314756 and it has its own corresponding color. So this is a data frame that we're going to be using to plot our donut chart. So from bokeh.transform we import cumulative sum, and the cumulative sum is what we're going to be using to find the start of our angle, or basically to find how much portion of our donut chart is going to be occupied by the angle. So the donut chart can be plotted using the angular wedge function from figure. So the x-axis here is 0 and the y-axis is 1. The inner radius is the radius that you are going to be giving to the inner smaller circle, and that we've given as 0.15. The outer radius is the radius of the bigger outer circle, and the direction in which our data is going to be plotted is in the anti-clockwise direction. So let's run this. And this is what our donut chart looks like. So the not murdered is this dark blue color portion of our donut chart, and when you hover over it, you can see how many values are present in the not murdered column. The same goes for murdered, and because we've plotted our data in the anti-clockwise function, this is how it's being plotted. So murdered, not murdered, and then finally you have the missing values. The way that you can interpret this graph is that you can say that most of the people were murdered during the game, but most of the data is missing. So we can't say for certain whether the majority of the people were murdered during the game or not, because the number of missing values can make a huge difference. And the number of people who were not murdered and the number of people who were murdered are very close to each other. Like their total values are very close to each other. Next, we will create a data frame of sabotage as fixed and minutes and change the column name and add T in them. So this is basically what we're doing. We've created a data frame which has the number of sabotages fixed and the minutes. Now let's just take the 3 sabotages which were fixed, which is 0, 1 and 2, and create a data frame out of all of these. So each of these individual data frames just contains these individual columns. To make a simple scatter plot with only one legend, we can pass the data and use scatter to make the charts. So basically we're just plotting the scatter chart in Bokeh here. And this is what our minutes scatter chart looks like. Now we're plotting this for 1t. We're plotting the minute at which one sabotage was fixed. And another cool thing about Bokeh charts is that you can always zoom into them or zoom out of them to better see where your data is plotted. So this is a scatter chart which has only one variable, which is 1t and the minute at which it was plotted. To make a scatter chart with more variables, we are going to need to use circle, which is a method of figure object which we've already seen before. The circle is one of the many plotting styles which are provided by Bokeh. You can also use triangles or many more. You don't have to make each point a circle. So we're going to be plotting So we're going to be plotting the sabotages fixed and the minute at which they were fixed. And we're going to be plotting 3 different circles of 3 different colors. I mean, each of them correspond to how many sabotages were fixed at what time. 0 sabotages at what time, 1 sabotage at what time, and 2 at what time. So let's run this. So as you can see here, when 0 sabotages were fixed, these were the times. When 1 was fixed, this was the time at which it was fixed. And when 2 was fixed, this is the time that it was fixed at. Now the x-axis is our minutes and the y-axis is the sabotage. When you hover over it, you can see various information about where each circle is plotted. So this has an index of 10. The data xy will tell you the exact x coordinate and the y coordinate, and the screen xy will tell you the screen pixels on which it is plotted. So now we've taken a look at pie charts. Let's move on to histograms. So what exactly is a histogram? Histograms are used to plot numerical data according to the range that they fall into. The data is plotted in the form of bins or rectangles, and the y-axis corresponds to the amount of data present in a certain range or at a certain point. So this is what a histogram looks like. This is a histogram of the distribution of minutes. So the x-axis has the range within which this data falls. Like over here, the first range is from 0 to 2.9 and the second one is from 2.9 to 5.8. Each range has a value of 2.9 and the corresponding y-axis or the height of the bins tells us how much data is present within this range. So this is how you can read histograms. Now let's see how we can plot them using Python Bokeh. Now let's see the distribution of minutes in the Among Us game. We will use hist to plot a histogram. So basically we're just going to be plotting the minutes of our game. We're going to be using the df min column for this, and we're going to be converting it into an integer. So this is the column that we're going to be plotting. Let's plot this. Again, we're going to be using the plot bokeh function here because it makes plotting data frames very easy. The kind of data frame that we're going to be using is the histogram or hist, and the title of our graph is going to be distribution of minutes. So let's run this. Now this is what our histogram looks like. Now this is when we've only plotted one variable, which is minutes. Yeah, so another thing that you can plot is a stacked histogram. A stacked histogram is when you plot various histograms on top of each other. So let's see how this works. For a stacked histogram, we want to see if the game length has a correlation with the amount of imposters and crewmates in our game. So to do this, we're going to be creating a small data frame which has the game length and the team columns combined. So let's do that. And this is what this looks like. So all you have to do to plot this in the form of a stacked histogram is use the hist function again. So let's see how that is done. And let's give this figure a size of, say, 750, 350 size. So let's run this again. And this is the stacked histogram that you get. We have two different columns which are plotted on top of each other versus the game length. So basically this tells us that when the game length was between 0 to 0.9 minutes, the number of imposters was way higher than the number of crewmates. And the longer the game went on, the number of imposters decreased and the number of crewmates just kept getting longer and longer. Now, obviously, you can say that the number of crewmates is decreasing as the game goes on too, but this is because the imposters would have killed off most of the crewmates. As you can see here, towards the end, there are no imposters, which means that most of the imposters were rejected and the crewmates won. So now we've taken a look at histograms. Let's move on to bar plots and understand how exactly they're different from histograms. So in histograms, you have plotted numerical data distributions as of yet. In bar plots, you plot for categorical data. It also uses bins to plot the amount of data. When the bins are stacked on top of each other, it's called a stacked bar chart. This is basically what a bar chart looks like. The difference is this does not have its own range. Each bar is used to represent a categorical data, and the height is used to tell us how much of that categorical data is present. So now let's see how we can plot a bar plot. So again, we're going to be making a small data frame of the task completed and the value counts of how many tasks have been completed. To plot a bar plot, we're going to be using plot bokeh again, and the kind of plot that we want to plot is bar. So let's run this and see what we get. So here is your bar plot. The task completed in this case is categorical data, and the counts basically tells us how many value counts fall into each category. So 0 tasks completed are 69, 1 task completed is 117, 2 tasks completed is 10, and so on. From this bar chart, you can say that the most number of tasks completed is 7 and the least tasks completed are 10. Now let's create a stacked bar chart and let's see who wins, imposters or crewmates. To create a stacked bar chart, what we're going to be doing is that we're going to be creating a different smaller data frame of team and outcome. To make sure that the bar chart is stacked, all you have to do is include a stacked attribute in your bar function and change its value to true. So let's run this and see. And here you can see that we have a stacked bar chart. So you can see that crewmates who have a lot more data have won 981 times and lost 780 times, while imposters have lost 205 times and won 216 times. So the crewmates have won significantly far more than the number of times imposters have won. Now let's take a look at stacked vertical bar charts. So far the bar charts that we've been looking at have been horizontal, which means that the data goes upwards. For a vertical bar chart, we're going to be seeing if all tasks have been completed or not. So in the data frame column, all tasks completed, we're going to be replacing the values of yes and no with tasks completed and tasks not completed. We're also going to be creating a smaller data frame of the outcome column and the task completed column. To plot a stacked vertical bar chart, you are going to be using Python bokeh.bar h function, and you're going to be changing the stacked attribute to true. This is what a stacked horizontal bar chart looks like. So over here we can see that the missing values is represented by blue, task completed by orange, and task not completed by green. Here you can see the total outcome. You can see how many wins, how many tasks are completed, and how many tasks are not yet completed. And the same goes for losses. You can see how many losses have occurred, how many tasks are completed, and how many tasks were not completed. This is a very good way of representing a lot of data in a relatively smaller area. Now, the way we can interpret this graph is that we can say that finishing the task will automatically ensure that the crewmates have won. So there's a higher number of people who need to complete the task to win the game. Another very unique type of bar chart that you can have is a bidirectional bar chart. So let's plot a bidirectional bar chart in which the bars will be going both ways, to the left and to the right. We're going to be plotting a horizontal bar chart over here to make it easier for you to see. To have a bidirectional bar chart, you need positive values and negative values. The center is going to be at 0. So here we're going to be making the loss feature as negative by multiplying the loss feature with the -1 value. So here we go, the losses are all negatives and the wins are all positives, right? Now let's run this and see how many losses and wins have occurred for each user. So user 1 has 42 losses and 58 wins, but you can easily see whether they have won more or lost more by comparing the height of the bars for the wins and the losses. So we can easily say that in this scenario, user 1 has won more times than they've lost. The same can be said for user 2, where the wins bar is significantly higher than the losses bar. So this is how you can plot and understand a bidirectional bar chart. So we've taken a look at how we can plot bar charts and the various types of bar charts that are available to us in Python Bokeh. Now let's take a look at area plots. Area plots is a combination of the line and the bar chart when the area below a line is shaded. Using an area chart, we can see how the values of different groups change over a period of time. The area chart has different baselines to show the vertical range of data. Here we've plotted the sabotages fixed versus the minutes at which they were fixed at, right? So these are the minutes, and the sabotages fixed are of two types, 0t and 1t. So the number of minutes that we're considering here is somewhere around 28-ish, right? And 0t, as you can see, has a way higher value. So one really good thing about area plots, especially in this case, is that they have two ranges. And they have another range on the y-axis, which tells us how the number of sabotages fixed is ranging. So 0 sabotages fixed, you can see how the value keeps fluctuating and how the value changes for different minutes. And the same can be said for 1t. Now 1t has a baseline which is over here, which is just above the 0t baseline. This doesn't necessarily mean that this is where 1t starts and this is where it ends. This just means that it ranges from 0 all the way here, and we can compare very easily how 0 sabotage is fixed and 1 sabotage is fixed range or change with respect to each other at the same time. Now the first thing that we're going to be doing to plot our area chart is that we're going to be creating another data frame. This is called df minutes, which is going to be comprising of the minutes column of our data frame and the sabotage is fixed column of the same data frame. For df min, we're going to be renaming the columns to 0t and 1t. And the only columns that we're going to be considering out of the 5 different columns that we have are the 0t and the 1t column. We're going to be combining all of these together in a format which can be plotted by using Bokeh, and column data source helps us do this. It helps us convert our various data frame columns into lists. Next, we're going to be using the figure function, and we're going to give our figure a width of 400, a height of 400, and the title of sabotage is fixed versus the minutes at which they were fixed at. To plot a stacked area graph, you're going to be using vArea underscore stack function from the figure module. You're going to be passing in your y parameters, which is y0 and y1, because we have two different y parameters here, and the x parameter, which is df minutes. The color that you're going to be using is gray and light gray. The legend labels are the names that you've already put here, which is 0t and 1t, and the source of your data is going to be this column data source. Now let's run this and see how our area chart looks. So this is our area chart. We've gotten two different sabotages here and two different times at which they occur, which is 0t and 1t. The minutes tells us how many sabotages were fixed at each time, basically how long it took to fix a sabotage, and the minute during the game at which they occurred. Now let's take a look at the layout function of our Bokeh library. The layout function will let us build a grid of plots and widgets. We can have as many rows and columns or grids of plots in one layout. Using the layout function, we can see various graphs at the exact same time. Mainly used for designing dashboards, it lets you build grids of plots. So this is basically what your layout function will help you do. This is going to look very good in a website because it's going to arrange our plots in a way that we can easily see all of them and understand all of them without any loss of data. This is also arranged very neatly, which is exactly what the layout functions allow us to do. So now let's take a look at how the layout function can be implemented in Python Bokeh. Now of the layout functions, there are many different layout options which are available. You have the column function which allows you to display plots vertically. And you have the grid function which lets you display plots in the form of grids. Now, for example, let's say that we want to make a dashboard layout in Bokeh. We are going to be considering 3 different charts. The first one that we're going to be considering is a lollipop chart, which is done here. The next one that we're going to be considering are 2 pie charts. So this is how you plot a lollipop chart, and I'll show you what exactly a lollipop chart is in just a minute. The first thing that you need to know is that the first graph that we're going to be plotting is going to be a graph which has the user ID versus the outcome of the games plotted on it. So what we're going to be doing here is that we're going to be creating a single data frame which has all of the user IDs present in it along with the user and the wins that the user has obtained. Now using this, we're going to be plotting it in the form of a plot in decreasing order where we have the top 10 users who have won, which basically means that the users who have won the most number of games out of all the users in consideration. So figure 1 segment will basically help you plot a line which has a width of 2 and a circle will be at the very top of this segment. So lollipop chart is going to be a horizontal line with a circle at the very top. Sorry, the next graph that we're going to be plotting is going to be a murdered and not murdered and missing values pie chart. And the last thing that we're going to be plotting is a donut chart of the teams. and the values within them. So these are the three different graphs that we're going to be plotting, and these are just us creating the graphs and plotting them. The main logic is over here. The main logic is that you want to set a layout in Bokeh as to how you want to see the charts. So the layout that we are going to be looking at is that we're going to be having a lollipop chart at the very top and two smaller pie charts at the bottom, right? So we have three figures here. And the first thing that we're going to be doing is that we're going to be giving these figures a line color of none. The axis is not going to be visible and the axis labels are not present for these figures. This is the main function that you're going to be looking at. This is your layout. Using the grid layout function that you've imported here from bokeh.layouts, you're going to be creating a grid. And how does the grid know where the figures are? So you've divided the grid into two. This is evident because you have two main figures here, which are separated by a comma. So this tells the grid that the page is going to be divided into two. The first figure, which is on top, is going to be figure 1, and the figure at the bottom are figure 2 and 3. This means that the bottom half is going to be further split into vertically. Let's run this and see what our layout looks like. So here you have it. Your entire page is divided into two. The first one has the figure 1, which is the lollipop chart, and the bottom half of our page has two figures, which are the two donut charts. The bottom half is divided exactly into two, as you can see here. This is because that is the grid layout that we wanted. So this is how you can use the layout function in Python Bokeh. It is extremely easy. All you have to do is create a layout by using the grid function, or you can also use the column function. The column function will plot it in the form of a single column vertically. Using the grid function, you can plot figures vertically as shown here. So when you separate them by commas with respect to each other, they will be plotted vertically, and when you group them together and separate them with commas internally, they will be plotted horizontally. So now we've taken a look at how we can use a layout function. Now let's see how we can make interactive graphs with the help of Bokeh. Over here, we're going to be using Bokeh to design a dashboard which is used to represent the horsepower in cars. We are also going to make our graphs interactive and see how maximum information can be conveyed with the help of a single graph. So here we have multiple different cars, and along with the cars we're also going to be given their horsepowers, a little bit of other information about them, and their images. And over here, as you can see, we have a very simple vertical bar chart. But let's see how we can make it interactive and convey all the information that we have in our single data set on this one bar graph. So the first thing that we're going to be doing is importing all of our important necessary modules. We're obviously going to have the pandas modules, which is going to be imported to work with the data frame that we've given. Apart from this, we're also going to be importing figures, output file, show, save, and column data source from bokeh.plotting. We already know that the figure function is used to plot different types of graphs which are given. Output file is just used to see our file. The show is used to display our graphs, and save will help you save your graph. Now, the column data source is the core of most Bokeh plots. It provides the data to the glyph of your plot. When you pass sequences like Python lists or NumPy arrays to a Bokeh render, Bokeh automatically creates a column data source with this data for you. So this is basically what you're going to be using to pass data onto your Bokeh glyphs. Apart from this, we're also going to be using a hover tool function, and from the transform function, we're going to be importing factor CMap. We're going to be importing a palette color, which is going to be various shades of blue. And we're going to be importing components from the embedded function of Bokeh. Let's just see how we can use all of these and the different things that they do. The first thing that you're going to be doing is reading in your car's data frame and creating a column data source so that you can easily parse this data onto your bokeh glyphs. So let's run and import all of our various required functionalities and import the data as well. So this is what your data set looks like. We have 8 different values in our data set, which are the names of different cars, their horsepower, their price, and a hyperlink of an image. This is what our data set looks like. We have only 8 columns. So using this data set, we're going to be plotting a horizontal bar graph. Again, we're going to be calling our figure function and we're going to be giving y range to our car list. The y range is basically just going to have the different values which are going to be present on the y-axis. We've given the plot a width of 800 and a height of 600. The title of the plot is Cars with Top Horsepower and the x-axis label is horsepower. The tools that we're using here is pan, box select, zoom in, zoom out, save and reset. So these are tools that you're going to be getting on the right side of your plot. Now let's render our glyph or render our graph. The graph that we're going to be using here is the horizontal bar graph. So the y-axis is going to have cars and the right, or basically the height of the entire bar, is going to depend on the horsepower. The left is going to start from 0 and the height of each bar is going to be 0.4. The color that we're going to be giving is going to be a palette of blue. So each different car will have a different color of blue associated with it, and the color of blue which is associated with it will depend on the car list. Now fill alpha 0.9. The source is your source data that you have over here, which is the column data source of our data frame. And the legend is going to be car, which basically means that your entire plot is going to have the legend of car. Now we're going to be adding the legend. This is us giving the legend its orientation. So the legend is going to be vertically oriented. The location is going to be on the top right, and the font size of the text car of our legend is going to be 10 px or 10 pixels. We're also going to be adding a hover tool. Inside this hover tool tips will basically tell you what you're going to be seeing in the hover tool box. So we're going to be creating this with the help of an HTML format. The first thing that you're going to be seeing is the name of the car. The next column will have the price of the car, the horsepower of the car, and the image. Now the image is in the form of a hyperlink, and this is going to be auto-populated in your hover tool. The width of the image is going to be 800. So we are going to add all of these hover tools to our P image, and we're finally going to be showing you the graph and what it looks like. So this is your bokeh plot. Here the title of the plot is Cars with Top Horsepower. This is your legend, which is cars. The name of each car is given here along with the color which is associated with it. Here are the different tools that we have. You can save this, you can reset it, you can zoom out, you can zoom in, you can select the boxes, and you can pan your image. So here we're zooming in, here we're zooming out. If we save this, the plot automatically gets downloaded in your system, and if you reset it, the image goes back to exactly what it looked like when it was first opened. Now here you have the names of the different cars on the y-axis, and you have the various horsepowers on the x-axis. Let's take a look at our hover tool. So here you have the name of the car which is on top, you have the price, and you have the horsepower, and as you can see, you have the image which is populated instantly from the hyperlink that was available to us. Now, the color palette associated with each car gets darker the more the horsepower of the car increases. So here we have cars with top horsepowers which are arranged in an ascending order from the top and a descending order from the bottom. So this is another way that you can use Bokeh to create extremely interactive and informational graphs. Here in just half a page, and this is us making a huge plot, right? We can also decrease the size of the plot if you want to. But basically in half a page, we've conveyed all the information ranging from the name of the car to its model to the horsepower that it has, its price, and also its image. And this is also a very good way to compare it. So these are just some functionalities which are provided in Bokeh itself. No other data visualization library will let you work so well with graphs and will let you customize your graphs to this extent.
With that, we have come to the end of this tutorial. I hope the session was interesting and informative. If you liked it, please let us know in the comment section below. Also do subscribe to our channel and stay tuned for more from SimpliCode. Till then, stay safe and keep coding.